Science or chaos? You decide, but something's about to blow. Boom! First, we light a candle. Not just any candle, of course. We use a massive lighter because apparently we're not doing science unless it looks mildly dangerous. We're not lighting a candle. We're summoning a fire god. Next, we take a balloon and fill it, not with helium, not with any fancy gas, but with our own mouth air, straight from the lungs, featuring a special guest appearance from today's lunch. We bravely lowered that balloon over the candle. And boom, it pops. Shocking, right? Who would have thought that rubber and fire aren't best friends? But don't worry, we've got a backup plan. We grab another balloon and this time we fill it with water because apparently the kitchen sink is now part of the science department. We hold that balloon over the candle. And it doesn't pop. Physics? Witchcraft? Nope. Just science. The water inside absorbs the heat, keeping the rubber cool. The heat transfers into the water, not the balloon, so it doesn't burst. That's heat transfer and specific heat capacity at work. But we're not done.
Another one.
Now we take a bottle of Pepsi. Not to drink, obviously. That would be way too logical. We're here to bully soda in the name of science. We take baking soda. Not for baking cookies, but for brewing chaos. Instead of dumping it in directly, we get fancy. We pour the baking soda into a balloon. Because science is all about making a mess look intentional. Then we carefully open the Pepsi and stretch the balloon over the top like it's wired with explosives. Now we wait. The soda starts bubbling like it's screaming, "Why me?" And the balloon starts inflating with all that fizzy revenge gas. And just this experiment needs is fire. When baking soda, a base, meets Pepsi, an acid, they react to release carbon dioxide gas. That gas fills the balloon and causes all the fizz. It's a classic acid-base reaction, producing gas through a chemical change.